Welcome to Mars Saga, your gateway to the Red Planet. Subscribe now and join the journey.
Mars ranks among the most studied worlds in our solar neighborhood, and it stands out as the only planet where wheeled robotic explorers have been sent to roam foreign ground. Over many decades, missions by various space agencies have accumulated strong evidence that Mars once enjoyed a warmer, wetter climate with a much denser atmosphere, long before it cooled into the cold, dusty world we see now. The planet's name traces back to Roman myth, Mars, the god of war, a fitting label because of the planet's blood-tinged appearance. Ancient Egyptian observers called it Her-Dashir, literally the Red One, a name that also reflected its striking hue. Today, the label Red Planet remains common because iron-rich minerals in Martian soil and dust oxidize, producing the rusty colors that dominate its surface. Origins and habitability. While scientists do not expect to find thriving ecosystems on Mars today, the real focus is on detecting evidence of ancient life, chemical signs and fossils left behind when the planet was warmer and surface liquid water was widespread. With a mean radius of about 2,106 miles, 3,390 kilometers, Mars is roughly half Earth's diameter. To help picture that scale, if Earth were the size of a nickel, Mars would be about the size of a raspberry. At an average distance near 142 million miles, 228 million kilometers from the Sun, Mars orbits at about 1.5 astronomical units. From that separation, sunlight needs roughly 13 minutes to reach the planet. A Martian day, a sol, lasts about 24.6 hours, very close to Earth's 23.9-hour rotation period. A Martian year equals about 669.6 sols, which corresponds to approximately 687 Earth days. The planet's axis tilts by approximately 25 degrees relative to its orbital plane, comparable to Earth's 23.4-degree tilt. This tilt produces seasons much like Earth's, but Mars's seasons are longer and vary in duration because of the planet's more elliptical orbit. Spring in the northern hemisphere, autumn in the south, can last roughly 194 sols, while northern autumn, southern spring, is nearer to 142 sols. Northern winter with southern summer spans about 154 sols, and northern summer with southern winter runs around 178 sols. Moons and small satellites. Mars is orbited by two small moons, Phobos and Deimos, likely captured bodies from the nearby asteroid population. Their irregular, potato-like shapes result from insufficient gravity to pull them into spheres. Their names come from Greek mythology, companions of the war god Ares, and fit the martial naming tradition. Phobos, the inner and larger moon, bears deep grooves and many impact scars and is gradually spiraling inward. In tens of millions of years, it may either break apart or crash into Mars, possibly creating a temporary dusty ring. Deimos, smaller and more distant, is covered in loose regolith that often obscures crater detail, giving it a comparatively smoother appearance in some regions. High-resolution imagery has vividly shown these contrasting surfaces. Rings and formation. Mars does not have a ring system today, although disruptions to Phobos in the distant future could create a transient ring of debris. Formation and internal structure. When the solar system settled into its present architecture some 4.5 billion years ago, Mars accreted from a disk of gas and dust and became the fourth planetary body from the Sun. Like the other terrestrial planets, it formed a dense central core, a rocky mantle, and an outer crust. Estimates suggest Mars' core spans roughly 930 to 1,300 miles, 1,500 to 2,100 kilometers in radius, and probably contains a mixture of iron, nickel, and sulfur. A solid mantle envelops that core, perhaps between 770 and 1,170 miles, 1,240 to 1,880 kilometers thick, beneath a crust composed of iron, magnesium, aluminum, calcium, and potassium minerals that ranges from about 6 to 30 miles, 10 to 50 kilometers in depth. Surface colors and terrain. Mars presents a range of muted earth tones, brown, gold, and tan, overlaid by its characteristic red cast. The oxidation of iron in surface rocks, soils, and airborne dust give distant views their ruddy appearance. Although Mars's diameter is smaller than Earth's, its dry land area is comparable to Earth's continents. Over billions of years, volcanism, impact cratering, crustal motion, and persistent dust storms have carved a complex and varied landscape that ranks among the solar system's most intriguing. A massive canyon. The immense canyon system Valles Marineris stretches roughly 3,000 miles, 4,800 kilometers, a span comparable to crossing from California to New York, and reaches widths near 200 miles, 320 kilometers, and depths on the order of 4.3 miles, 7 kilometers. By scale, it far exceeds Earth's Grand Canyon. The tallest volcano. Mars hosts Olympus Mons, the largest volcano in the solar system, a shield rising to heights about 3 times that of Mount Everest and standing upon a base as large as the state of New Mexico. Evidence of a watery past. Geological markers reveal Mars once had flowing water. Networks of ancient valleys, delta deposits, and former lake beds attest to a time when rivers ran and episodic floods reshaped the surface, especially around 3.5 billion years ago. Today, enduring liquid water on the surface is rare because the atmosphere is too tenuous to support it for long. Most water exists as ice near the poles or beneath the surface, and there are hints of briny seasonal flows that trickle down slopes and crater walls. Atmosphere and climate. Mars's atmosphere is thin and largely composed of carbon dioxide with smaller amounts of nitrogen and argon. Fine dust suspended in the air gives the sky a hazy red tint rather than the blue we see on Earth. This sparse envelope also offers limited protection against impacts from meteorites, asteroids, and comets. Temperatures on Mars fluctuate wildly. In some equatorial spots, sunlight can warm the ground to around 70 degrees Fahrenheit, 20 degrees Celsius under midday conditions, while in shadowed regions and during cold seasons, temperatures can plunge to roughly minus 225 degrees Fahrenheit, minus 153 degrees Celsius. Because the atmosphere is so thin, heat escapes rapidly. At the equator at noon, you might feel spring-like warmth at your feet, around 75 degrees Fahrenheit or 24 degrees Celsius, and near freezing at head height, about 32 degrees Fahrenheit or 0 degrees Celsius. Occasional global or regional dust storms can envelop the planet, lofting enormous amounts of fine material and sometimes obscuring the surface for months until the particles settle. Magnetism and ancient fields. Mars lacks a global magnetic field today, yet areas of the southern crust preserve strong remnant magnetization, a fossil imprint implying that a planetary magnetic dynamo once operated about 4 billion years ago. Human exploration and robotic visitors. Mars has been the destination for many robotic explorers, orbiters, landers, and rovers, each built to examine aspects of the planet's geology, chemistry, and weather. Instruments on these missions reveal rock structures, chemical makeups, and patterns of surface radiation, helping researchers piece together how Mars altered over eons. Orbital surveys map mineral distributions and pinpoint sites of interest, while surface rovers traverse plains, inspect outcrops, and sample ancient deposits to answer questions about past environments. Seasonal and environmental dynamics. The Martian environment is dynamic. Seasonal cycles shift frost and dust. Carbon dioxide trapped at the poles freezes and sublevates, and local weather phenomena like dust devils and regional storms redistribute material. These processes subtly change atmospheric pressure and surface appearance with the seasons, and they play a major role in sculpting the planet's surface over time. Human perspective and future missions. Studying Mars informs planetary science, astrobiology, and plans for human exploration. Upcoming missions aim to return carefully collected samples to Earth, probe subsurface ice deposits, and test technologies for habitation and resource use. Researchers hope these efforts will determine whether organic molecules in rocks are biotic in origin or products of non-biological chemistry, and will assess how accessible water ice might support long-term human presence. Each finding refines mission strategies and deepens our understanding of planetary evolution. In short, Mars remains a place of both familiar echoes and alien differences. Its landscapes mirror some terrestrial processes, yet are shaped by forces and conditions unique to the planet. The Red Planet continues to offer crucial insights into how worlds evolve and whether life might arise beyond Earth. Thanks for watching, yet subscribe to get daily notifications.